Hello and welcome to today's presentation, Altium 365, our electronics development platform, or short EDP. My name is Fabian Winkler and I'm here to tell you something about Altium 365, what we want to achieve with it, and later I will show also the workflow, how everything is working. So most of you probably know Altium by its ECAD software, Altium Designer. But Altium is so much more than just PCB design. Altium is about creating great products. And for that you need more than just electronic engineers. You need system engineering, electrical engineering, procurement, software development, mechanical engineering, manufacturing, and even more. And our goal is to connect all of them. With that said, in our today's fast-paced environment, development teams are asked to develop products faster and faster. And today, products are developed 3 times faster than in the 1980s. And with this compressed times, teams are challenged to develop such products in shortened periods. So nothing is happening sequential anymore. Everything happens in parallel. So requiring fast iterations and collaboration across various departments. However, for developing electronics, there are not so much technologies to manage its processes. For software, everything is laid out, and the same for MCAD tools, where we have the MCAD tool for designing the design, we have the PDM for managing the data, and we have PLM for overseeing the whole development process. Electrical engineering hasn't kept up with that, and we see this firsthand from our customers. And where our customers are using Altium Designer for the schematic and the layout, but for other processes, everything is quite less efficient, using manual data exports, local files, printouts, and so on. So with that, here's an example how it's currently working out. So here we have an electrical engineer and a hardware engineer. Both are using the local libraries. That means they are often out of sync. We have a software engineer who often has outdated schematics to work on the firmware. We have the manufacturer who is not involved until pretty much the very end. We have the technical project manager who needs to tap on everyone's shoulder to get the latest updates. We have procurement, who is also not involved until pretty much the very end, just to find out that 80% of the components needs to be replaced due to price and availability issues. Then we have a mechanical engineer who has to work closely with electrical engineer and hardware engineer to make sure that the PCB fits inside the enclosure. And for that, they have to hassle around with and exporting step files. We also have the engineering manager, product manager, and system architect, all very disconnected from the whole process. And this has some real costs. We conducted a research with Forrester, and there's also industry research by Lifecycle Insights. And our findings are that engineers are spending up to 159 hours on administrative tasks alone. Or that up to 80% of PCB designs require replacements of parts due to cost or availability issues, and taking up to 40 hours for sourcing them. And without design review and proper simulations, the Lifecycle Insight study shows or estimates that an average project needs 2.8 board respins. Overall, this is costing a team of 6 engineers $400,000 per year, and this is not even counted in for product launches, delays, and so on. So what is the solution to all of this? It's to bring everyone on the same table and connect them to make them collaborate. And we're developing Altium 365 to do exactly that. So we have requirements. You can create your requirements directly in Altium 365. It's not there yet, but it's coming soon. Then we have a centralized components library and your BOMs from your designs using all the supply chain data we offer from Silicon Expert, Z2 Data, or Octopart and IHS Market to get lifecycle information automatically added to them. Then we have the schematic, PCB design, everything using this, the same unified data model. And you can also release your projects in a very controlled way. And we even assist you with assembly for your prototype boards, and we have a manufacturing portal to make you collaborate more with the manufacturers. This is a different view of Altium 365 from a more architectural perspective. At the basis, we have Amazon Web Services, and Altium 365 relies on AWS, and everything is running on AWS. And it's built up securely from the ground up, and we have multiple security certifications like SOC 2 Type 1 and SOC 2 Type 2, and more are even on the way. We also have an instance of A365 running on AWS GovCloud, providing companies in the US even more control and security if needed. Something similar is, by the way, coming for Europe as well with Sovereign Cloud. Then, on top of it, we have different modules specified for different disciplines. For example, with engineering design process management, you can manage your whole design files. Then with supply chain management, we are including the procurement and supply chain team. With risk and quality management, we connect the quality people with the design process. And in the future, we also have engineering management, where we have tools to lay out the whole workflow to define the whole development process. At the bottom, we have tools we integrate them with. We don't want to replace them, but we want to let you use the tools you are already using and to work with your broader development ecosystem. Great. So this is the video how Altium 365 is working. We are starting in the workspace, and in here you can see your projects, your BOM files. You have your menu on the left side. You can even create subfolders where you can organize your projects. And first we want to go to workspace members and invite one of my colleagues. In this case it's yellow, because our goal is to collaborate, and therefore we want to have all the team who's involved in the development process in our workspace. Next, we go to the projects. And in here, we can see, for example, our PCB project, a BOM file, and we can then also click on the three dots for the project, where we have multiple options. You can open it, share it, move it, edit it, clone it, and create a managed BOM or delete it. In this case, we want to share it as well. And this is a different way how you can provide access if you don't want to invite someone to the whole workspace. You can add someone, you can define if this person has view or edit access, and then you can invite them. Let us take a look how it's looking like. Clicking on shared with, and then you can see that Hugo is just a guest now. So he is not invited to the workspace, he is only access to this specific project. Great if you're working with contractors or external people, customers. And for workspace members, you can also even decide which access level they have, if they can view, edit, or if they have no access at all. Okay. After we have that done, we can close this view and open our project. We can do it by double-clicking on the project. It's then loading up the design. There we have first all the schematics. You can select the schematic you want to look at. You can then select components or nets. You can see then on the right side all the information for this component, on which side it is. In this case, this component is on the bottom layer. You see supply chain information like the life cycle, and we also have the part choices with stock and price information. You can also select the net, where you also see the layers used and also the schematics used for this net. And if you now select a different view, for example, the PCB, we have this cross-probing feature, so this net is already highlighted here as well. And this is also working for the 3D view, where we have a 3D representation of all your tracks, the vias, the pads, which is quite nice. Additionally to that, we also have your reference files in here for the documentation, and your BOM file, which reflects your active BOM document, also with all the supply chain information needed. But you can do a lot more. For example, we are going to the IMU and debug schematic, and here we are seeing that the capacitor is missing. So what we can do now is we can place a comment to tell the engineering or the design team about this issue. With the comment, you can select specific components or nets, or you can drag your own area where you want to highlight something. And then with the add function, you can mention one of your teammates. In this case, I will just ping myself. You can also assign a task. And then you have also the ability to draw something if you want. In this case, it's just a symbol of a capacitor to make it even more clear what is missing here. You can still specify it even more, like adding the requirements for this capacitor if needed. And click on post, and then this comment will be shown also in Altium Designer. You also have a snapshot attached to it, so that you can always see how the project looked at the time where you when you place the comment. And yeah, as the next step, I would say we should solve this issue, and you can easily do it by going to Open Project in Altium Designer. In a second. Then it opens this specific project in Altium Designer. You can see it's popping up. I will open now the first schematic to have the overview. And then we can go at the bottom right to panels and open our comments and task panel. And after doing this, we are already seeing that the comments is showing up in here, and I can click on it. And when it opens the specific schematic where I have placed this comment, I can even see my drawing in there, which is pretty nice. What you can also see, we have a priority, and we have like a little status for the task with to do, in progress, and resolved. So we can now set it to in progress and start working on it. To do this, I will go to the components panel, and then I search for the same component in my library. So we also have a parametric search, which could be quite useful. And in this case, we can see there is no component available. So what are we doing now? We have to create a new component. We can do this with the manufacturer part search. It's already showing up in the components panel. And in the manufacturer part search, we are seeing now components which are matching our criteria. And then we have here on the left side, like the preview image, we have the manufacturer part number, the manufacturer. We have the life cycle state, it's this green bar. Like green means it's in volume production, red means it's obsolete. We also have yellow, which means it's not really recommended for new design. Next to it, we have this little IC icon. This means we already have symbols and blueprints attached to this component. Then there is a description, some supply chain information with price, minimum order quantity, and stock. On the right side, we have a ton of parameters from Octopart, and in this case also from Silicon Expert. And there is even more. We can even expand it a little bit more if we click on Show More. So there are really a lot of parameters with operating temperature and so on. We have the latest PCN updates, and you can also see all PCNs from the past. Here we have the symbols, or the models, the symbol and the footprints, the data sheets, and at the bottom we also have alternatives. Here from Silicon Expert with a rating, while A is showing that this is a direct replacement for this component. So I prefer in this case, at the bottom we also have IHS Market, where we have a different rating. But in this case, I prefer the Samsung part because it's a little bit cheaper. Minimum order quantity is 10, but still fine. I'm not planning to order less than 10 boards at the time. So I want to add this component to my library. Here I can just click on the Save button and start the importing process. I can first select the component type I have defined myself. In this case, it's a capacitor. And for my capacitor components, I have a component template behind of that. So here first, only the parameters will be imported, which are in my component template. Of course, I can overrule it and still say that I want to have all parameters. You can also see that the symbols will be not taken because I have a symbol already in my component template. I also know I have footprints in my library, so I don't need to take these new footprints. I prefer to reuse the ones I already have. And for the data sheets, it's only enough if I have one. I can click on OK, and it's importing the data now in the single component editor. Here I can still change everything if I need to. First, I will change the name. I still have the possibility to change all of the parameters if I want. So they are not set into stone. I can still add them if needed. We have the part choices here at the bottom. We can still add more part choices as alternatives. And we can also give it a rating. Like in this case, I'm giving the Samsung part a rating of 5 stars because I want to use it still as a primary part. While clicking on Add, it will take the name of the component and searches for it. And now we are getting the similar search results as before. And we can add more part choices. In this case, I'm just adding one. And they are showing up here now as an alternative. I can also give it a rating. As far as this part has a lower rating than the other one, it will be the secondary solution. At the next step, we still have to add the footprint. Here I will choose an existing one, and I can search through my data in the workspace. In this case, the footprints are stored under components, then models, and footprints. Here I can search for the specific name. And then select the right one. I even get a preview image, how it's looking in 3D, or I can also switch to the 2D mode. I click on OK, it's attached to the component, and you also have this little pencil icon here, and if you click on it, you can still edit your models. I'm doing it here for the symbol, and then you are getting a warning showing that this symbol is already used by 46 other components, and now you have two options. You can create a copy, and then it will create a new symbol just for this component, or you can edit the shared model and update all 46 components afterwards as well. And this is helping a lot to keep the library pretty consistent. So we will not do it in this case. We will close this and then save the component. So we will go to Save to Server. We can add some release notes for the commit. And afterwards, it's uploaded to the workspace. This component is available for all my colleagues who have access to the workspace. And another big advantage is that multiple people can work at the library at the same time. So what we can do now, we can just drag and drop this component over to our schematic and insert it. We will place it. I will add a designator to it. In this case, I'm doing it manually because it's a little bit faster. You also have automatic ways to do it. And afterwards, we can resolve our task. So now we have updated the schematic. Now we also need to update the layout itself. So we go to design and then update PCB document. It will detect all the changes between these two documents, like between the schematics and the PCB document. In this case, it's just this capacitor. I can see the nets attached to it. And in this case, it's looking fine, so I can execute the changes. And it will transfer this capacitor to the PCB document. I can close this view now. Here's the 3D view. I will switch to the 2D view. And what we can also see is that we are not using any designators or for the top overlay. So first, I will go to the properties panel of the new part and hide the designator. So next, we have to place this component. And for this, I will switch to I will flip the board because this component has to be on the bottom. And now I still need to flip over the component also to the bottom side. So you can still see it still has red pads, which means it's related to the top layer. But while selecting the component with the mouse, you can press the L key to flip the component as well. And then we can place it where it belongs to. So I will place it, in this case, at a polygon. And now you will see that the clearance will be added automatically. The clearance is defined by my designer rules I have defined before. And also the ground pad is connected with a polygon pure because it also has the same ground net. Okay, so we have this. We can save our document. And now on the right side, we see that some of these icons changed. And this is because everything is under version control. We have the green arrows, which are showing that we are still in sync with our workspace data, but some files have now this red circle. And this red circle means that this file was modified locally. So we can now click on Save to Server. We can add our comments to it. So we are doing a commit. We are using Git in the background for the version control. We can click on OK. It will synchronize our local files with the workspace, and now everything is in sync again. We even have a full project history where we can see what changed and who changed something. So you can do a right click on the project name, then go to History and Version Control, and go and click on Show Project History. And here you can now see, it's still loading, but here you can see who committed something, when was something committed. You can see the comments. And on the right side, you can also see that we have three different icons. Like the green icons means that something new was added. The red minus icon means that something got removed. And the yellow dot means that something got modified. You can also click on the three dots and then we have multiple options like download sources. You can compare something, for example, the schematic. I already starting the comparing process, but you cannot just compare the schematic, also the PCB and BOM. You can create a tag for milestones, for example. You can clone specific commits, and you can revert your local files to a specific commit. Exactly. So we see the new events are available. So it detected all the changes we did, and now also the component is showing up we just placed. And the nets as well, because this component is attached to ground and VCC5. In the meantime, the comparison report is also ready, and we can see on the left side all the differences between the different commits. We can click on it, and it will jump to the specific area where we have this change. Good. So our project is fine now. It looks ready to go. So we can create a managed release. And therefore we can use our project releaser. So we will do another right click on the project, select project releaser. And here we are using our output job files to create the outputs. And then we have the source data, we have the fabrication data, everything defined, and the assembly data for both variants. And this is also a nice advantage of a project releaser instead of using output job files. It's creating all the needed outputs with a single click, even if we have multiple variants. Here you can see I also have a design rule check attached to it. And after starting the release process, I will do it in a second, you can see that it will start with a design rule check. And this has a specific reason. Okay, first I have to create the items for the release. I probably have to do another commit as well. Let's do it quickly. And afterwards it will start with a design rule check. And the reason behind this is quite simple, because we want to make sure that we have no errors during our release. So if there is an error for the design rule check, it will abort the whole release process. In this case, it passed. So it continues with creating all the other outputs. Like it's collecting all the project files, it's creating the fabrication PDF, creating the Gerber files, the drill files, everything what is needed for the fabrication process. And for the assembly, we will have the pick and place files, the bill of materials, and this for both variants automatically. After everything is created, let's give it a few more seconds, we can upload our release to the workspace. We can still give it another comment. Click on OK, it will start the upload process. Should be quite fast. And then we can go to our workspace in the browser and see the result. You also would have the options to see all the data reports if needed, but we are not doing it right now. So back in the workspace, in the web browser, we can go to the releases, and now we see here our release. We can download all the files individually or download the full release. In this case, I want to manufacture now 10 prototype boards, so I click on Send to Manufacturer on the top right. I can define which packages I want to send to the manufacturer. Since I want to assemble the first prototypes myself, I will just share the fabrication files. I can enter the email of the manufacturer. In this case, I'm still using my colleague here for demonstration. And I click on Send. After it's done, it's showing up in the bottom left. But first, we want to change the lifecycle state. The lifecycle state is an internal lifecycle state where we can give and where we can say in which state it is. In this case, we want to change it from new design to in prototype state. And after we tested the prototype successfully, we can put it into in production state so that we always know which release data we can use or which not. For the manufacturer package that we shared, we can see who shared it, when it was shared, who has access to it. Like in this case, it's me and my colleague Yellow. And also which files we are sharing. If I click on the three dots, I can open it, share it further with other people, download it or delete it. If I delete it, also my colleague Yellow would have no access to it anymore. So let's see how it's looking like if we open it. So you're getting this nice overview. If you don't care about this, you can just download the package and start working on it. But we also have previews, like for example, if you click on fabrication, you can see your fabrication data and also this layer stack of this PCB. And what is quite nice in here, you can even place comments. So the manufacturer don't have to send around screenshots and share them via emails. They can place the comments directly in the design files. So we only have the comment right where the problem is. We see what the problem is directly in the context. Okay, let's assume our files are okay. PCBs are getting produced. Now we still need to order all the parts to assemble these prototype boards. To do this, I will create a managed BOM for this release. I will click on the three dots on the right and select Create Managed BOM. And this is for engineers and for procurement people working on this. More engineers for prototypes, more procurement for production. And with the managed BOM, you get a full view of your BOM with all the columns attached to it, with lifecycle information, library information. For example, for all the suppliers, we also have Silicon Expert parameters in here. We have data sheets, we have the link to the component library, and so on. So let's take a look at the dashboard, because the dashboard provides a nice overview of the state of our BOM. So what we can see, it's not looking too good. We have like one discontinued part. We have no alternates at all in our BOM. And the BOM coverage is only 84%, while we still have 6 different suppliers in our list. You also see the estimated years to end of life. If you click on something, it will filter the table view at the bottom, which is also nice. So you can filter all the parts directly in here. We also have compliance information, but in this case, I will resolve the issues in the Issues tab. So here we are seeing it. I click on the dots and they are filtered by it. Okay, let's go to the Issues tab. And here I see all the issues I have. I can define for everything if it should be no report, a warning, an error or a fatal error. So I can define it by myself. Here I will select the missing part numbers because we have a few parts without the manufacturer part number in here. And you can see there is this light bulb attached to the manufacturer part number field. And this means we have some suggestions. So you can click on it. You will get a list with some pretty nice suggestions. You can then select them. This is also working for microcontrollers, so not just for generic parts like capacitors. And we are using the description and the name for finding good fits for it. You also have this pad in here, so this is not really a component, it's attached to the PCB. So we have 2 options here now. We can even either disable checks for this row, or in this case, we will delete this row entirely because it's not needed here. We also have options to add new components to the BOM as well, or to add also new columns, for example, for notes or comments you may want to add. So looking at the issues, we see we have a lifecycle issue. So let's select it and solve this issue as well. This is a high-rows connector we have here, where we can also see the information. We can see that this part is not available anymore. There is no stock parts, and we can search now for an alternative for this part. So I will click on the manufacturer part number. I will get some suggestions, but you can see they are also not in stock. So I will use the advanced parametric search and then switch to the alternates mode. Here I see ratings from IHS Markit, but they are only 8, so these are not direct replacements. So I will use alternates from Silicon Expert, and here you can see that one solution is from Silicon Expert with a rating of an S. And the S rating says that this is a replacement from the manufacturer itself. So we will use this in this case. Also, the rest is looking fine, it's in stock. We have a price, compliance is looking okay, and years to end of life as well. So we have solved at least the most critical issues here in our BOM. So let's order the BOM. We can go to supply chain, and now first we can set the quantity, how many boards or how many parts we want to order. So we want to order the parts for 10 boards. We see the BOM coverage, but we still have 6 different suppliers. We can now use the order list preset, and we can search by lowest price, or in this case, all by Mauser. Then it will reload, and you will see that the dashboard will change, that most parts are now from Mauser. One part was not available in Mauser, so Fanel got selected in here. You also see that one part is out of stock. We can click on it, it will filter the view, and now we can select the order list and find another supplier we want to choose. So in this case, we want to select a new arc. So there's stock information, price, minimum order quantity, looking good. And now I want to change the Fanel part as well, also to new arc, to keep it more consistent, that we only order from 2 suppliers. So we also see the order price and the price per board. You can see that they are not always 100% in sync. This is because that some parts have a specific minimum order quantity, so we consider the minimum order quantity in the order price as well. After we are done, we can click on this shopping cart icon, and we can now buy with Octocart. Here we see Mauser and New York showing up. After clicking on Buy All, 2 browser windows will open, one for Mauser, one for New York, where all the parts from my managed BOM will showing up here, and I can directly buy them. So this is quite helping if you want to order parts for your prototype boards. Going back to BOM Portal, we can do even more with it. So first, we will release the BOM. So we will have a managed release here as well. And we can also enter release notes. We can release it and open the release afterwards. So we have 2 versions. We can even compare these versions to each other. We can publish it to the PLM, not a problem. While the comparison report is created, we can already change the lifecycle state for the first revision and set it to obsolete. It's now not showing up here, but it's not deleted. So you can still show hidden releases. And in the meantime, we can also create autofill alternatives. For example, if we want to add alternatives as well, we can set it to 2. It will choose part choices we have attached to the components. You can also check this checkbox and then use data providers like IHS Markit or Silicon Expert to add even more alternatives to it if you don't have them in your part choice list. So after clicking on autofill, it will select all the part choices as an alternative. And in this case, we had enough alternatives for 16 of our 37 BOM items. And you can see it that more rows were added for each line item. So going back to our comparison report, which is ready now, we can also see everything what we have changed in here. Like we removed the pad and then we changed quite some items that we added or changed the manufacturer and the manufacturer part number. Okay, so we ordered our PCBs, we ordered our components. So what do we want to do next? We want to assemble our board. And we can do this with Assembly Assistant. Assembly Assistant really helps with building up the prototype boards. Like previously, I have done it with printing out the BOM and the PCB view. And then I highlighted every 100 nanofarad capacitor in a specific color to know where it's placed. Now this is everything is done by Assembly Assistant. I see how many parts I have at the top, how many parts I have at the bottom. I can choose if I want to have it grouped or split it up by the sides. So yeah, I can see it for both sides. Here I have the settings. I can group it. I can also disable it if I want to do it. And afterwards I can click on Start Assembly. It will remove all components from the board, and then I can start soldering them one by one. If I'm done, I can click on Done or press the space key and move to the next component. And you will see it will place the component after I soldered it to the board. So in this case, I will just skipping through all the components. So it's really showing it pretty nice step by step how this is done. We'll flip also to the other side to show these parts as well. In the end, I can see how many pins are soldered and how much time it took for me. So I have a good estimations now how much time it will take to solder the 9 other prototypes. So yeah, this is how we build our projects, order the parts for it, and assemble them ourselves. So since we have this now, we maybe need to check our library and take care of the topic obsolescence management. Here we have the library health dashboard, which I will show in a second. So I can go back to my workspace, then to components. And here I have a library health and I can click on see details to get even more information. And here it's quite nice. I get a lot of information, but most critical is the supply chain area, where you can see I have 10 components in my library which are used in projects which have no supply chain information at all. There are 5 components which I used, which have stock issues. There are 10 components who have a risky life cycle state, and we can even click on it to get more information. We can select the component, we can see the details over there from IHS Markit and from Silicon Expert. And we can even see where this component is used. So we know now exactly which components we have to change. So let's go back to the dashboard. And here we also have protected supply chain issue, which you will get with Silicon Expert. And here we are using the years to end of life. And for this component, years to end of life is 1 year. So we can now, we now have two possibilities. We have the way to change the project as well, to change the life cycle of a component, to obsolete, to make sure that this component is not used anymore, or the other way would be to edit the part choices. With editing the part choices, you can do this also in the web. Just click on it, and when you can click on Add Part Choice, it will search through the name and find suitable alternatives. And then you can select the one you like the most. So for example, if we scroll a little bit down, we see that there is one part with the years to end of life of 16 years. So this one, also compliance information is looking good. This part is in stock, so we can use this part as an alternative. However, there is still more with Altium 365, for example, multicut, where we are supporting ORCAD files already, so you can upload your ORCAD files to Altium 365, place comments, and also create managed BOM files. We will also support KeyCut, Eagle, and PES in the future as well. We also have Cloud PLM synchronization, where you can sync your design files, release packages, BOM files, manage BOM files, your library with your Cloud PLM, so in this case Arena, Duro, and Windchill Plus. We also have a design review extension to give you a full design review process, where you can also attach files, tasks, and checklists. And we also have MCAD Co-Designer, where you can work together with your MCAD engineer. Instead of in and exporting step files, you can just press push and pull to transfer the data. Then in the MCAD tool, you can change the board shape of the board and sync it back to Altium Designer. We also have advanced copper geometry. This means that you can transfer your 3D copper information to the MCAD tool. Here we see it. And we also have rigid flex synchronization, which means that you can sync your rigid flex designs with your MCAD tool and even define the flex areas in the MCAD tool. Okay, that's all. If there are questions, I'm here and can answer them. So